Hello guys, so in today's daily dose, we are going to have a wonderful topic that is relay method, and we are going to see a wonderful question on the relay method. But before that, I would like to tell you that relay method is the only method for which to find out natural frequency, we need not to make any governing equation. If you go by Newton method, energy method, D'Alembert principle, or any other method, you have to make first governing equation. Relay method is only which will directly give you the answer. So to understand this, first of all, I am going to consider a spring mass system. Then we will go for that wonderful question which I am talking about. So my dear, initially we are having a spring like this. Okay. So let us say this is the spring with stiffness S. Now you are going to put a mass over it. Because of this mass, this spring is going to deflect by some amount, and obviously when the mass will be coming in equilibrium, after that the spring will not be getting deflected. So at that instant, spring is getting deflected by delta naught. At this location, mass is in equilibrium. This position of mass is said to be the mean position, and at this position there is no equilibrium, there is no vibration happening because body is in equilibrium. So this delta naught is said to be static deflection of mass. Static deflection of mass. So as I am saying, body is in equilibrium at this instant, we can say mg acting downward and S delta naught is acting upward. So for equilibrium of the body, mg will be equal to S into delta naught. So delta naught will be coming out to be mg by S. And this is static deflection of mass. So relay method says natural frequency is simply G by delta naught. Natural frequency is simply G by delta naught. And when you will be putting the value, omega n would be coming out to be square root of S by M. This is the expression for natural frequency. Why? Delta naught is mg by S. But this daily dose is not to teach you relay method. This is to do a wonderful question on this. So to apply the relay method, there are two things. One is there should be only one point mass. If there are more than one masses, we cannot go for relay method. The second thing, it is valid only for the natural vibration because it is based upon the conservation of energy of a system, not of the universe. So my dear, if that is the condition, if there is no friction, energy of the system will remain conserved. Otherwise, it is not. So damper should not be there. So vibration should be only natural vibration. Now, if you see this type of question, by looking at this, majority of the student will leave it. They will see it is very, very big and lengthy problem. But my dear, for such problem, relay method is just like a blessing. If you see only one point mass, in this question, 2-3 things are absent in the figure. I am telling you. Actually, here is a hinge support. Okay, and it is symmetrical, L by 2, L by 2, L by 2 and L by 2. So my dear, because of this mass, only one point mass, this would be deflected like this, and this would be deflecting like this. Means it is rotated by angle theta. This is also because this mass will try to go down. So we are interested in the static deflection of mass, that is delta naught. And we are considering this spring is getting compressed by delta 1. Why it will happen? Spring is deformable body. So mass will try to come down, because of that spring is getting compressed. This spring is also compressed by delta 1. And this spring is expanded by delta naught. So my dear, now first of all we need to find out delta naught. So by symmetry, if you take two symmetrical triangle, this and this, you may say, sir, why it is symmetrical? This angle is 90, this is 90. This angle is common. So when two angles are equal, third will also be equal. So you can say from here that, delta naught by L is equals to delta 1 upon L by 2. So you can write delta naught to be 2 times of delta 1. Now we are going to take moment, summation moment about O to be 0. When you would be going for summation moment about O to be 0, this is the point O. Then you know mg would be creating clockwise. So mg into L. Then the spring is getting compressed by delta 1. So it would be creating anti-clockwise. So minus S into delta 1 into L by 2. Then this spring is also compressed. It will also create anti-clockwise the force in the spring. So minus 3S into delta 1 into L by 2. This spring is expanded by delta naught. So it will be creating in this direction. So it will create anti-clockwise. Minus 2S into delta naught is 2 delta 1. Okay. Delta naught is 2 delta 1 into L. Putting it to 0. You know L will get cancelled out. So after cancelling all the length, what we are left with? We are left with mg is equals to, this is S delta 1 by 2. This is plus 3S delta 1 by 2. This is plus 4 S delta 1. So you can see this is by 2 by 2. So 3 plus 1 is going to be 4. 4 by 2 is going to be 2. So mg will be 6S delta 1. Okay. So from here you can write delta 1 is mg by 6S. So delta naught is mg by 3S. Now you know, my dear, that natural frequency of vibration G by delta naught, it would be, you know, G by what? It is mg by 3S. Putting this value, mg by 3S, answer will be S by 3M, sorry, 3S by M. Yes, putting the value of delta naught, what we are getting as delta naught, let us once again look at it. We are getting it as mg by 3S. So mg by 3S. mg by 3S. 3S by M. So guys, for such wonderful problems, they are definitely expected in GATE examination. Just stay tuned with us. We are coming like every Monday. I am coming with some wonderful concept or such type of wonderful problem. So goodbye guys for this wonderful daily dose. We will be meeting once again. Okay, goodbye.